Okay, here's a couple of gas law questions. First says a vessel has an internal volume 11.6. Okay, let me do my P1, V1, T1, N1, P2, V2, T2, N2. Internal volume 11.6 liters. Contains 2.8 grams. So every time I see grams, I can convert that to moles, right? So I'll be able to figure out with this one. And then they say, what is the temperature 25. So that's 25 plus 273.15. So that'd be 298. 298.15 Kelvin. And now they're asking for the pressure inside that vessel. So they're not changing pressure, volume, temperature, moles. So if I only have this information here, I know I'm going to be using the ideal gas law. So PV equals nRT. I'm looking for pressure. So pressure is equal to nRT over V. Now I can start plugging stuff in. But the problem here I have is I don't know how many moles. So I need to convert all of these into moles. And then I'll do both of them, but I could do two different things. I could find the partial pressure of each gas and then add them up, or just add up how many moles I have and then find the partial pressure of that. I'll maybe start there. So let's figure out how many moles. So I have nitrogen gas is N2, and so nitrogen is down here, is 14.01. So to find out the moles of nitrogen, and I'll do it up top here. So the moles of nitrogen are going to be equal to mass over molar mass. Mass is 2.80 grams divided by the molar mass. 14.01 times 2 would be 28.02 grams. So the moles of nitrogen, I'll do that on my calculator. So it's 2.8 divide 28.01. Okay, so that's 0.09996, etc. Okay, so it's moles of nitrogen. And now let's do moles. I should have done them all on the side here. Now let's do moles of hydrogen gas. So that's mass over molar mass, so 0.403 grams. This was grams per mole. Sorry, I forgot that. So that's moles. Hydrogen is 1.01 times 2 would be 2.02 grams per mole. So do that one. 0.403 divide 2.02. 0.1995, etc. moles. And then finally the moles of argon gas will be equal to the mass, 79.9 grams, divided by argon is 39.95. 39.95 grams per mole. Okay, 79.9 divide 39.95. Oh, it's exactly 2. It's equal to 2 moles. So now I'll add those up. So 2 plus 0.1995 plus 0.09996. So this is coming out to moles total are going to be 2.29946. And we'll just keep as many sig figs in the question as we can. So the pressure is going to be equal to moles, 2.29946 moles times the universal gas constant, kilopascal liters per per Kelvin mole times the temperature, 298.15 Kelvin, divided by the volume, 11.6 liters. So moles cancel, liters cancel, kelvins cancel. I wind up with kilopascals, which is a pressure, so that's a good thing. So let's take that number that we have and let's multiply it by 8.314. Multiply that by 298.15 and divide that by 11.6. So what I'm getting is 491.3746. So I would do sig figs. Looks like I have 3 sig figs. Oh, I have 2 there. It looks like they're given 3 sig figs in their answer. They must be using the sig figs when you add the Kelvin. So let's go 491 kilopascals. Is that an answer? Oh, no. They have all their answers in atmospheres. Great. So we can do that. 491.37. I'm just going back to the original number. Kilopascals times, there's 101.325 kilopascals in atmospheres, 1 atmosphere. So if I take that number that I just got, oh no, I deleted it, 491.3746 divided by 101.325, 4.849 atmospheres. So 4.85 atmospheres. I'd be going with that answer. Okay, that's a good one. Here's another one. So a gas is heated from 25 to 70. So this would be, well, let's do our thing. P1, V1, T1, N1, P2, V2, T2, N2. So my first temperature is 25. We just did that. That was 298.15. Temperatures 2 is 70. So 270 would be 343.15 Kelvin. Volume remains constant. Don't have to do anything with volume. If the initial pressure is 2.85 atmospheres, what is the pressure after it's been heated? Ooh, that sounds like a good Lussac law. So the moles are a wash. I don't have to worry about those. Now, if you haven't memorized that Lussac's law, you can, if you want. This is the combined gas law, N1, T1, P2, V2 over N2, T2. And we don't have to worry about volume because they kept it constant. So we get rid of that. And they also don't indicate that they added or lost any gas. So I can get rid of moles on that formula too. So I'm left with that, and that's Lussac's law. And they're looking for P2. So P2 is going to be this cross, P1 times T2, divided by the thing that's across from what you're looking for, T1. So P2 is P1, 2.85 atmospheres, times T2. Careful with that. Always make sure you're putting in the right one. Divided by T1, 298.15. Now, if I take a gas and I heat it up, I'm assuming that the hotter it gets, the more pressure there is. So I'm hoping my answer is bigger than 2.85. But let's try. 2.85 times 343.15 divided by 298.15. So my second pressure then, I'm getting 3.28015 atmospheres. Kelvins cancel. sig figs, 3 everywhere, so 3.28 atmospheres. All right, hopefully that helps you with that question.